Hi, this is Mike from Minimal 3DP, and today I want to talk about print speed. Recently, some of my favorite YouTube channels, including Filament Friday, CNC Kitchen, and Teaching Tech, have done videos talking about how fast or tweaking your printer profiles to print as fast as you can. And what I'd like to talk about is just some of the plus and minuses of increasing your print speed. Whenever I'm interested in a topic, the first tool I look at, particularly if it's research related, is Google Scholar. And so I've just opened up my browser to Google Scholar, typed in FDM print speed, and done a quick search. And then I've also limited it to any article since 2018 because I want newer stuff. And then I can just look down this list here, and what I do is look at the right hand side here for any articles that have either PDF or HTML, and if they do, I can open them up and then take a look. If you haven't used Google Scholar, it's very much a tool you should be looking at, particularly when you're looking at research related topics, or I use it all the time to see what different researchers found with 3D printing and to get ideas for making tweaks or changes to my printers. One of the main articles I found is this one, a systematic survey of FDM process parameter optimization and their influence on part characteristics. This article is worth taking a look at if you read anything, and you scroll through the article. There's a awesome diagram that shows various process parameters and what they affect. And if we look at print speed, we can say print speed affects surface roughness, dimensional accuracy, build time, of course, tensile strength, and then lastly, flexural strength. Now, why is this important? It's important because as you make changes to your printer, you're affecting characteristics. So if I switch back over to my research articles, I can look at this article that I found regarding print speed. And you'll notice that slower speeds, I get better dimensional accuracy. Also, they're saying I'll get better dimension. They found better dimensional accuracy with higher temperatures. They also found better tensile strength with higher speeds, and then of course minimal build times, which is what you would expect. Now this other article sort of contradicts that. This researcher tested on a single printer, and what he found that on the particular printer he was using, that he got pretty similar results with tensile strength, going between 50 to 80 millimeters per second. But anything over 80 millimeters per second, so it started to affect the strength of his part. Now, where does that leave us? Us as makers, we just need to be aware, and again, using this diagram, this is a good place to start. As you're changing and updating your profiles and changing the print parameters you're using to achieve, again, either better build time, better accuracy, lower costs, smoother surfaces, just keep in mind that each time you change any of these parameters, you're affecting the physical properties of your model. And again, depending on what you're printing, that could have serious consequences. Now, what are my recommendations? I would recommend that moving forward, particularly if you're depending on what you're trying to do with your printer, again, speed things up, lower costs, lower energy usage, etc. Create your own experiments and experiment and see what that print parameter is doing for you. It might be printing quicker, but is the part weaker? Or is the part stronger? Is the surface quality not exactly where you need it? in a future video, I'll go over how to set up some experiments and what some of the recommendations I can make. I appreciate your time today. If you have any questions about print parameters and how they affect the quality of your printed object, please post them in the comments. I'll try to get back to you as soon as I can. Thanks. Have a good day.